Hi guys, welcome back to Random Tutorials by Mary Ann, and today we're going to be doing analytical geometry. So grab your pen and your paper and join me for the ride. Think I'm a rapper, you know, something. Rapping skills set aside, let us begin with the first question. So this question is taken from November 2015 and it is a grade 10 past paper. So it begins by saying in the diagram, C is a point on the y-axis such that A is 0 and 4, B is 4 and negative 4, C and D is negative 4 and 2 of vertices of a parallelogram ABCD. K is a point 0 and negative 2 1 over 4, and L is a point on AB such that KL is parallel to CD. To make life easier for yourself, better make notes on what you know about whatever quadrilateral you are given. So in this case, we are given a parallelogram, and what we know about a parallelogram is opposite sides are parallel and equal, and the diagonals bisect at the same point, and it cuts them. Bisect, of course, means cuts the diagonals in half. All right, then we can start answering the questions. So the first question begins, calculate the length of the diagonal DB. So if we are looking for length, we are going to use the distance formula. To start answering the question, we need to calculate length of DB. So I'm going to use the simplified version to calculate length, all right, the distance formula. So DB root of x of b minus x of d squared plus y of b minus y of d squared. Guys, I have a really ugly handwriting, so please bear with me. Alright, so I'm just going to say equal to, gosh, my lines are so skewed. Okay, let's try that again. There we are. Alright, x of b is 4 minus the x of d. We're going to say bracket negative 4 bracket again squared. Alright, we say negative. Be very careful over here. Alright, let me just see if I can show you what I'm trying to say. I want you to be just careful over here. Alright, if it's a negative, if you have a negative coordinate and you're writing that coordinate next, alright, like negative x of d, in which x of d is negative, you put in brackets negative number. Alright, I hope that you understand, because then it gets quite confusing if you say negative negative without putting in the brackets. If you say negative negative with the brackets, it just indicates that the bracket is now going to be multiplying. Alright, it's going to be multiplied with negative with a negative number. Then plus y of b is 4, no, negative 4, and y of d is 2 squared equal to the root of, so it's going to be 4, a negative times a negative gives us a positive. Alright, so it's 4 plus 4, which is 8, and 8 squared gives us 64, plus negative 4 and a negative 2 gives us a negative 6, and a negative squared gives us a positive, and 6 squared gives us 36. So this becomes 36, and this is all the root of 100, which gives us 10 units. Gosh, I have such ugly handwriting, but I hope that you bear with me over here. I hope that you understood what we did. The next question, we need to calculate the coordinates of M, which is the midpoint of DB. Midpoint of DB is also where the diagonals bisect, because this is a parallelogram. Alright, so just keep that in mind. So to get the midpoint, we're going to use the midpoint theorem, which states that x of dB, y of dB
is equal to the x of d plus the x of b. Divide that by 2, semicolon, y of d plus the y of b, divide by 2, and close our brackets. Alright, and this is all equal to, since we're trying to find what's on the left hand side, I can just work with the right hand side by keeping my equal signs. The x of d is negative 4 plus the x of b, 4 divided by 2. The y of d is 2 plus the y of b is negative 4 divided by 2. I don't know why my handwriting decided to be this ugly today, but anyway. Alright, so negative 4 plus 4 gives us 0 divided by 2, which is still 0. And 2 plus negative 4 gives us a negative 2. Divide that by 2 gives us a negative 1. And those are my coordinates for, just erase that, looks really ugly. And those are my coordinates for our midpoint.
Hope that was helpful. Now let's get back to it. Now the next question, we need to get the gradient of AD. Alright, so we have the coordinates of AD. We can definitely get the gradient.
The gradient of AD, we're going to use the gradient formula, which is MAD equal to y of d minus y of a all over x of d minus x of a. Alright, this is basically the gradient formula, which says the change in y over the change in x of 2 points. So the y of d is given as 2 minus the y of a, which is given as 4 all over the x of d is negative 4 minus the x of a, which is 0. Alright, so on top we have 2 minus 4, which gives us negative 2 all over negative 4. Alright, the negatives then cancel, so let's use a different color pen to cancel. This becomes positive. 2 divided by 4, you can leave it as 2 divided by 4, or you can write the simplified version, which is 1 over 2. And that's the gradient of AD.
So now the almost 100th question. Get or prove that AD is perpendicular on AB. So for perpendicular lines, what you need to know is the gradients multiply and are equal to -1. Alright, for perpendicular lines, the gradients multiply and are equal to -1. So if the gradient of AD multiplies the gradient of AB and it gives us a value of -1, then it means that those two lines are perpendicular. Alright, now we've already calculated the gradient of AD. Now we're going to calculate the gradient of BD and compare the two values. Alright, if we multiply them and it gives us -1, then it means that these two lines are perpendicular. For parallel lines, the gradients are the same. For perpendicular lines, the gradients multiply and equal to -1.
To get the gradient of AB, we're going to say the gradient of AB. Let me get this in black. So the gradient of AB is equal to the y of b minus the y of a all over the x of b minus the x of a. And that's y of b is -4, y of a is 4, x of b is 4, and -0. So -4 gives us a -8 all over 4, and that gives us -2. So now to check gradient AD, if I multiply it with gradient AB, it's 1/2 times -2, which gives me -1. Therefore, it means AD is perpendicular to AB. Alright, why? Because if lines are perpendicular, the gradients, multiply, and equate to -1.
Question 3.5, it says, give a reason why parallelogram ABCD is a rectangle, and the reason for that is the corner angles are 90 degrees. All right, so the corner angles are 90 degrees, and that's why parallelogram ABCD is a rectangle. Okay, so we're going to move on to 3.6. Calculate the equation of KL in the form y equal to mx plus c. All right. Now, if we look at our diagram, KL is parallel to BC, and it's also parallel to AD. So for parallel lines, the gradients are the same. All right. Parallel lines, gradients are the same.
As stated, the gradient of AD is the same gradient as KL because they are parallel lines. So gradient of AD is the same gradient as KL, which is equal to a half. I'm going to change the coordinates of K to look like something I know. So this is 0. I'm going to make this a proper fraction because it's much easier for me. So the y value is just -9/4, and the rest we just substitute into the equation of a straight line, which is y minus y1 equal to mx minus x1. Alright, where x1 and y1 represent the coordinates of k and m represents the gradient. So a half x, I'm substituting these coordinates here. Just check, I'm substituting these coordinates over here. Alright, where this is my x, this one is my x, and this one is my y. So this is 0 and y minus -9/4. Alright, then I'm going to multiply in the negative over here, this a half over here, and over there. So it's going to be y plus 9/4, because a negative times a negative gives us a positive, equal to a half x, and a half times 0 gives us 0. Then I'm just going to make y the subject of the formula, and that's y equal to a half x minus 9/4. Okay, the line did not work. Let's take it back, remove the line, and that's the equation for KL. Alright, let me recap. The gradient of AD and the gradient of KL are the same because they are parallel lines. Then we're just going to substitute the coordinates of K into y minus y1 equal to m brackets x minus x1, or you can use the equation y equal to mx plus c, and then you just make y the subject of the formula.
I know that's how you probably feel, and trust me, I feel the same way, but we're almost done. Let's do just the last question. So the last question states, write down with reasons the coordinates of C. So looking at the diagram, the coordinate of C is on the y-axis. Alright, so if it's on the y-axis, it means my x is 0. And if we have an x of 0, it means the only missing coordinate we have is the y coordinate. So we can use the gradient because we have the gradient of BC, which is the same gradient as AD or of KL. And therefore, we will be able to calculate the coordinates of C. A lot to take in. Let me show you how.
So as we've already stated, the gradient of BC will be the same gradient as AD because they are parallel lines. So the gradient of BC will be the same gradient as AD. So the gradient of BC is the change in y over the change in x, and we've already stated that the x coordinate of C is 0 because it is a y-intercept. So y of B minus y of C over x of B B minus x of C. And the gradient of AD is a half. Okay, so we're going to just substitute. Y of B is given as negative 4 E minus Y of C, which is what we're looking for, all over x of B is 4 minus x of C, x of C is 0, okay, equal to a half. Alright, now let me continue this page. So I'm going to say a half equal to, we have on top negative 4 minus y of c all over 4. Alright, so to get them under the same denominator, I will cross multiply. So that's what I'm going to do. Let me cross multiply in a different color. So pink, this is going to multiply with that, this is going to multiply with that. So it's going to be 4 times 1 equal to negative 4 minus y of c, all in brackets, multiply by 2. And this 2 is going to multiply with everything. Okay, so this is going to be 4 is equal to negative 8 and negative 2yc. Then I'm going to get yc alone, so I'm going to take the 8 to the other side, and that becomes a 12 equal to negative 2yc. Then I'm going to divide both sides by 2, and I'm going to continue here. Therefore, y of c is equal to negative 6. Alright, and it is a negative because it's below on the y-axis, and all of those values are negative. Alright, and that is how we answer all of the questions of analytical geometry.
I hope that this video was helpful. If you still want to do a lot more other questions, tune in into the next video where we're still going to be doing analytical and Euclidean geometry, just in a grade 11 standard. Alright, don't forget to comment, like and subscribe, and tell your friends and your friends' friends to definitely tune in into this channel. See you next time. Bye.